Nginx is the company behind the popular open source project trusted by more than 450 million sites. They offer a suite of technologies for developing and delivering modern applications. The Nginx application platform allows enterprises to modernize legacy, monolithic applications as well as deliver new, microservices-based applications. Check out infoq.link/Nginx for more information.
Hello and welcome to the InfoQ podcast. My name is Wes Rice and I'm here with Charles Humble, the chief editor of InfoQ. And today we're live at quant AI. We absolutely did not rehearse that, by the way. So today we're doing a special panel. It's after day one of quant AI. And this panel is with a variety of people that represent different data personas. And what we're going to do is talk about building a data science capability. So today we have Stephanie Yee, a data scientist at Stitch Fix. Welcome, Stephanie. We have Matei Zaharia, assistant professor of computer science at Stanford and chief technologist at Databricks. You may have heard Apache Spark. We have Sid Anand, who is the chief data engineer at PayPal. And we have Sup Ranjan, who is the director of data science at Coinbase. And as I mentioned, I'm joined by Charles Humble, the chief editor of InfoQ.
Thank you very much.
All right, so to start this off, I'm going to ask each one of you to tell me about a project or projects, in some of your case, that you might be working on right now, and then answer this question. For your persona, and you can identify that persona, what do you feel is the most important skill set in AI, ML, data engineering? So Stephanie, we'll start off with you. What projects are you working on, and how would you answer that question?
Yeah, sure. So I'm director of client algorithms at Stitch Fix, and in that capacity, I oversee things where we are modeling clients. So this is things like marketing, product, forecasting. I think that there's a couple of interesting projects that we're working on. One of them is really like, how do you think about taking a really scientific approach to performance marketing, for example? In terms of the different skill sets that we look for,
What's the most important skill set
the
for a
most
data
important
scientist?
skill set for a data scientist, just in general? I would say problem framing. So when you think about, like, if you're taking a scientific method to something, it's making sure that you're answering the right question. And sometimes I think, especially when you're working closely with cross-functional partners, they can ask a question, and it's a really good question, but the solution is actually the answer to a different question.
Okay, hi, I'm Matei Zaharia. So both at Stanford and at Databricks, I'm working a lot on platforms for machine learning or infrastructure for machine learning. So a specific project at Stanford, I'm part of a lab called Dawn, which is a group of 4 faculty members focusing on infrastructure for usable machine learning. So basically our sort of thesis there is there's a lot of work, a lot of existing systems that do machine learning training, but just training a model is a small part of the overall work. So we look at all the other pieces you need to get a successful model, including data preparation, labeling, how can we reduce the cost of labeling data so that you can actually use machine learning in more domains, and production, serving and monitoring and debugging. So I'm working broadly in projects in that space. And in terms of what do I think is an important skill for a data scientist, it's a role that requires interacting with so many aspects of a business that you really need this ability to talk to different stakeholders and understand their perspective, everything from the business itself to the technical sort of algorithms to the engineers who need to deploy or rely on this type of model. So I think more than many engineering style jobs, this requires that.
Hi. So as a data engineer, which is my persona, in my current role, I oversee multiple data engineering projects, and some of them span the online world. Obviously, PayPal processes payments, so it needs to have a very highly available databases and connectivity framework to databases. And then for the purposes of things like risk analysis, it needs to have a pretty robust analytics practice. And the two of them need to be tied together. So how do you take structured data that's being written at a high pitch to a transactional store and then ship it for offline transformation, enrichment, analysis in a way that's high fidelity? and that actually points to probably one of the first projects that I've taken on, is that all data that lands in our databases, whether it's at PayPal or one of the 4 or 5 companies we bought, that are basically spanning, 7 NoSQL and 5 RDBMS databases, how do we capture it and then ship it to, say, a Kafka stream or offline to any number of persistent sinks where data scientists and other sort of analysts can analyze it and do stuff with it, and do that in a self-service way that's essentially always on, never down. So that's sort of what I'm working on now. And when I look for a member of, say, my team, I look for somebody who has breadth and depth in data engineering. It may take someone 15 years, if you think about it, right? If you go from company to company and you work on different parts of data engineering, to have a very full portfolio of talent. So you should know sort of how a database works under the hood, how streaming systems work, how graph processing works, how graph search works. I'm looking for somebody who, or people who have a mix of that talent, and it often takes about like 15 years of exposure to that to sort of pick it up. But that's what we look for.
Hi, everyone. So I had all of data at Coinbase, and we've stayed away from categorizing anyone as a data scientist, even though officially my title still says data science. For the following reason, because the word data science just means something very different to everyone. One of my favorite questions that I ask anyone who is joining my team is, I ask them to just describe themselves as a histogram, where on the x-axis they have things like SQL, stats, ETL, which is data engineering, and event streaming, like Spark, and building machine learning models, which is feature engineering. And I've noticed that that's really one of the best questions I could be asking anyone who wants to join a data team, because very naturally you figure out all the different types of personas, right? And then the second question I ask them, okay, where do they want to see themselves like a couple of years from now? So that then gives me direction as to where should I actually focus their efforts towards a particular project. And I am a software engineer by training, and I identify myself as a machine learning engineer, essentially a software engineer who picked up machine learning. And the other, because of the way we formulated as a histogram, different personas, they fall out. One is someone who just really excellent at SQL is a data analyst. Someone who knows SQL very well and also knows stats very well is a quant. And then someone who does machine learning, feature engineering is an ML engineer. Someone who does ETL and enjoys bringing data together into data warehouse is a data engineer. And someone who really enjoys building machine learning pipelines, event streaming, is a machine learning infrastructure engineer. So that's at least how we've broken it up.
So following on from that then, could you maybe talk a bit about what roles data professionals play within a company or within your companies?
Right, so we have all 5 of those personas, and each of them are tasked with different things. And for instance, data analysts and quants, they're tasked with helping the different business units or products with respect to deriving insights from data and helping with a particular business metric. Data engineers and machine learning infrastructure engineers are tasked with essentially laying the foundation for what our next generation architecture is going to be. And machine learning engineers are also matrixed into different products. So they could be matrixed into risk, where they are actually working on reducing payment fraud or preventing compliance risks, or they could be matrixed into growth, where they're helping with user acquisition campaigns and optimizing those campaigns using machine learning.
What about the rest of you?
That's a hard question to answer, because I feel like at every company I've been at, there's been various fuzzy lines. At the startup I was at, I think the people who call themselves data scientists did mostly data engineering work. At LinkedIn, I felt like the data scientists were mostly statistics people, and they were kind of not interested in touching code, and then they were kind of forced into touching code. And then other places, there are very clear separations. Data engineers will build a platform for you, and all you sort of have to do is generate some model profile that we can ship into production, and we'll take the production side of it. So I think PayPal is so large, I don't think each division probably runs it slightly differently. The group I'm in mostly is just end-to-end data engineers. And the ML people, the people who are developing the risk models, I would say, they use the platform we build.
So I was going to say, is it a function of size? Is it at a smaller company, people are just wearing more hats? At a larger?
I think in a small company, it's hard to hire specialists.
Sure.
And it's hard, you have to pivot. And so I think Matei wanted to.
Yeah, so I can talk a little bit about this. So at Databricks especially, we see sort of hundreds of different data science teams from different companies, which are organized in different ways. And you can kind of see the pros and cons of each one too. There isn't a single solution that's like perfect for everything. So I've seen sort of two broad types of organizations. One is kind of a vertical specific team. So you have the same team of people that does the data engineering to import data. It does, reporting. It does machine learning models and training and so on. It's the same set of people, and they work as a team. And this can require, people who learn multiple of those skills, or at least a team that's cohesive where you can do this stuff. But the benefit is that they're all working in one vertical problem area. So like, let's say they're doing all these tasks for, I don't know, smart meters or something like that. And then the other thing I've seen, especially at large companies, is you have a separate like data science or a machine learning infrastructure team. And then the benefit with that is you can have a specialist in each area, but the downside is now people become blocked on that team, and also they may not understand the vertical use cases very well. So you can easily cause things to be, delayed as they go through the organization. But on the other hand, you're doing everything in a more consistent way. So there are pros and cons with both of these models.
So I'd say at Stitch Fix, so we have what our org is called the Analytics and Algorithms org. And you can split it into 3 different groups. So one is the data science team, and I'll partition that a little bit later. The next is what we call the data platforms team. And the idea behind this team, or their mandate, is to make tools that can help make the data science team more productive. And then the third one is what we call analytics engineering. So they're tasked with sort of making self-serve tools for business partners. Within the data science team, we actually organize functionally. So we try to map to our business partners. So Stitch Fix styling companies, we've got sort of a styling algorithms team, merchandising algorithms team, and then client algorithms.
So what makes a good data science professional? Do you need a computer science background? Do you need a maths stats background? What are the kind of different career paths that people have taken to end up in your organization?
We sort of take a very broad view. Like, a lot of it is very context dependent. So if I was at a company prior to this, and it was a Java shop, and we would sort of roam around looking for these unicorns who happen to know both Java and have a PhD in statistics. And I mean, I'm sure that these people exist. It's just hard to find them, so then you just become a recruiting firm. The way that I look at it, though, is that everyone sort of has their superpower, and every context is going to need a different superpower. So like, we do have some people, they have computer science backgrounds, and then they'll be more sort of on the machine learning engineering side. We have other folks like who are astrophysicists or who just are neuroscientists, and they just sort of approach problems in different ways. So we try to have a broad spectrum of people.
Yeah, I think it will take a while until you have a set of people sort of either who learn all the skills in their normal industry job, or people who graduate who like have all these skills from their education. So I think a lot of the work is figuring out, with the backgrounds that people have, and how can you set up the infrastructure and set up a process so that you have an efficient team as a result. There's a lot of work in that area to try to reduce the barriers between different people.
Yeah, and I think to your point about centralized versus, I remember in LinkedIn, the search team had a relevance team and a search infra team. And the separation of the two orgs was a file, right? It was like Conway's law, right? So the responsibility of the relevance team was to generate a file, and the responsibility of the infra team was to consume the file. And that actually worked quite well.
So again, going back to the histogram analogy, so I've found it to work incredibly well. For instance, quants are usually folks who've had an advanced degree in a STEM field, and they have picked up stats, or they already know stats, and they've picked up some software engineering. And then we also see a variety of software engineers who've picked up machine learning, and they know not only how to create a model, but also deploy it into production. So those become our machine learning engineers. And data engineering is essentially like, that's the simplest one to define, because and as is machine learning infra folks, because those are essentially back-end developers who know what does it really mean to actually move data across and build microservices, right?
Okay, we have a question over here.
So as some of the panelists was talking about, training the model is just part of the process. I wonder if there's work being done, or there's a tool already that can standardize or having a general format for the model so that it's easier to wrap the model to make a lightweight API?
Yeah, I mean, I think the short answer is that unfortunately there isn't a standard tool to package models yet. There are many different sort of attempts that go to different, to different extents there. So one extreme is like, oh, your model is just a Docker container with a REST API. This can be good if you're doing, just a few predictions at a time, but it's maybe very heavyweight if you're trying to, for example, use your model in a Spark application and apply it to lots of data. Like, do you really want to make a REST call for every item? And then for specific frameworks, there are formats like Onyx for deep networks, or like the TensorFlow model format, or different ones. I think it would be great if there was a way to sort of standardize on this, but it just hasn't happened, and people have been trying to do it for a while.
And sometimes people, the interface is a NoSQL store, where it's a key value lookup for some sort of models. And to your comment about packaging in like a Docker container, the other idea is like the classifier, the scorer gets packaged with the model, and then they're co-versioned, and then it's like an AMI or a Docker image that gets shipped. And if there's a problem with it, you don't know if it's a problem in the data or a problem in the score. You just roll it back, because you can never know. And that's what we used to do at LinkedIn and even in my startup.
I have a question regarding like the talent shortage, especially in data science and deep learning. How do your companies cope with that? Because like there's definitely less people than needed in the market. Do you have like special programs you do internally to get your people up to speed, or kind of an approach at all to deal with that situation?
How do you hire managers for data science?
Yeah. There's lots of boot camps out there, so we definitely seek for talent from there, right? And then the other thing that's at least worked quite well for us at Coinbase has been just providing access to all the data to all the analysts and even folks who actually want to become analysts. And we've seen some amazing results out of that. People, when they're incredibly motivated, they actually pick up things themselves. And then we've had folks who've transitioned from risk analysts to data analysts, or risk analyst to a data scientist, or risk analyst to a software engineer. So we've had all sorts of spectrum over there.
So I want to challenge you on that, though.
Sure, yeah.
When Sid just answered, he said it takes 15 years to get all the skill sets that you need to hire someone who's doing things. Yet you just said boot camp. That's a long boot camp, I'm just saying.
I think that's a data engineer. That's a very specific skill set, right?
The other part of the data scientist is the domain knowledge, right? So even if you bring someone in, they have to learn the domain, because they need to understand what heuristics make sense, how to evaluate the models if they make sense.
So I think in terms of recruiting, one thing that I think Stitch Fix did really well in the beginning especially is they invested in creating an environment that's really, really friendly for data scientists. So we actually, when we're recruiting, I mean, you're obviously having to compete against a lot of companies, but we're in the very fortunate position where it's like, oh, well, like, you can come and run and play here, and it's really fun. And everyone's like, wow, that's really cool. But it is really an upfront investment. There's a component of what we call tech branding. I think on some level we had to do this all along, because it's sort of hard to convince like a neuroscientist to be like, hey, you should go into women's retail. So there was like okay, no, hold on, we need to really try at this. But it helps with recruiting even now.
Stephanie, I want to follow up to that. Stitch Fix is a company that has something like 90 data scientists and less engineers. Can you talk a bit about the philosophy of that many data scientists for your business?
The philosophy, or? Yeah, so I would say it's interesting. So when Katrina, the founder, started the company, one of her things was, I think that we can use machine learning and data science to actually change the way some of these companies work. And our chief algorithms officer, which it's crazy that we have one, but I think in 10 years everyone will, he was, I think, one of the first 10 employees at the company. So this is one of those things where it's like you had to start at the ground up.
Right.
So that's
Makes
sort
sense.
of, yeah.
I think there's another question over here.
That's actually a good segue. So the podcast is titled Building a Data Science Capability. I'd like to get the panelists' feelings on where do you start to build that, right? Where do you start? Because you all seem to have a mature capability there, but for companies that don't have it, what's the beginning? What's the first step? And then the building blocks to maturity.
Great question.
Yeah, it's funny. I was actually talking to the CTO of a company who was thinking about this as well a while back. I think that there's a couple things. The number one thing, though, is that you have to sit there and you have to say, what do you want this capability to do? right? Like a capability is a task to be done, and like what's the goal? It's very easy for people to sit there and say, you know what, I'm going to hire a data scientist and they're going to do things. And then that's not often successful if there's not a very clear mandate. So you got to start with that.
Yeah, so I've seen, again, different organizations that are at different stages of doing this, including many that are just starting out. And what I found is actually the first thing that everyone has to get right is the actual data itself, the pipeline to collect it and clean it up and just understand it. And if you don't do that well, you can't really learn anything from it after. And if you do it well, even very simple questions or like observing changes in it might reveal a lot of insights. So that's the thing we spend a lot of time on, is like helping people figure out, what data they should bring in, what else they need, and how to reliably, collect and compare that. So I think if you start anywhere, you don't need to do even any machine learning, and you'll get value from this.
Matei, let me follow up with that question. So I had lunch today. So quant AI is all about artificial intelligence, machine learning for software developers. That's what we were really trying to focus on. I had lunch today with an architect, and he works on cloud-based platforms. We'll call him a Java architect. I'm not sure if he was, but we'll say he is. And he said, I don't know where to start. I don't know what the state of the art is. I don't know what I don't know. Would your advice be to start with just collecting data, start collecting input, and then start to look at that data?
Well, so I think, again, as Stephanie answered, you have like a business goal or question that you want to tackle with this, and it's important to pick one. I think if you just say, oh, we'll set up a data science team and, just check in 6 months later and see whether they found anything, it's not going to work. But there are many specific things you can say that you want them to do. You can say we want to increase lift on this metric by this amount. You can say we want to understand customers' usage so that the customer success team can talk to them in advance, stuff like that. So you pick some specific goals, and then for those you figure out, okay, what data do we need to collect? Maybe in many cases there are a bunch of logs or JSON files somewhere, no one's looking at them, and then figure out how you actually want to organize it to ask questions. And as I said, you can get much of the value using very simple analysis. Of course, once you do that, you'll want to do more to get the last 10-20%, but doing anything simple is much better than not looking at it at all.
Sure.
Yeah, I agree with that. When I joined LinkedIn, actually what was interesting is almost all of the relevance models were heuristic models. They're hand-built models. And what's interesting is, I always find this funny when I go to a conference and a data scientist or ML person is like say, I cannot reveal the features I'm using. And it confuses me because the features are very specific to the data that company collects. For example, LinkedIn has information about your connections and about your profile, your professional profile. Like Airbnb doesn't have that. No one else has that, right? So the set of, like, say, 20 features that LinkedIn has, no one else has. Like, it knows your profile, it knows who you're connected to, it knows your job title, it knows things in your job history. Netflix has different things. It knows your watch behavior, it knows your address, it can probably infer your gender or something like this and your age. It can probably do some of that, but it has a different set of data. So all of these companies have different sets of data. From that data, you will do feature engineering. Then when you go to a conference, they never share it. They say, I can't share this feature. That's very important to me, and I never understood it.
One thing I wanted to say was that I think every company could benefit from a data science capability. Like if you have any process which is fairly manual, let's say insurance, right, or some sort of credit scoring, for sure you can actually just extract all of the data and apply machine learning to do your credit risk assessment in a more automated and intelligent manner, right? Or if you are an e-commerce company which is just trying to grow, right, or acquiring users, of course you have already collected some data. You can go and try to optimize that growth, right, or the cost of user acquisition. But yeah, the key I think over here is having an exec team which really buys in to how access to data and data intelligence can improve either the top line or the bottom line. And the second is, of course, building a solid foundation where you can actually bring all the data together in a data warehouse, which allows other people to actually play with it, as Stephanie mentioned, right?
What if this person's in infra and he wants to use machine learning to improve performance of the servers that are running? What's the state of the art? What are people doing?
One of the key things is anomaly detection,
Yeah,
right? So which is, you want to know if you have fairly complex distributed system as to, where did things go wrong? Where did it break down, right? If you have a complex MapReduce task, maybe, or you have a complex, DAG, which is doing event streaming and event aggregation. So in such cases, I think, like gathering all of that data from the logs and the CPU and the network usage and throwing it all there in some sort of a anomaly detection can actually really help you debug a very complex system. Anything to add?
Yeah, I'll just add, so one of the other professors in the Dawn group at Stanford, Peter Bayless, works exactly on a system for large-scale anomaly detection called Macrobase, and I've been also helping with like some problems related to that recently. And it's in some ways like what it does is very simple. Is you just take two tables of data that have attributes and a metric, and it does basically it computes a difference, and it finds the groups of attributes that have the biggest difference in the metric, and it can quickly explore the different potential combinatorial groups and give you the top ones. It's super simple, but what they found with this is that many different companies, once they plug it into their data center or serving system type metrics, they immediately find anomalous groups that are actually a problem. And what happens in infra often is you're collecting metrics, you have all the historical data, but no one looks at them unless there is a problem and it's severe enough that someone calls, and then they dig in and they say like, oh, every content item on this CDN is like not being served in this country or something. But you can't proactively catch these. So with this type of system, and there are many other anomaly detection methods too, you quickly see a summary of the top ones, and you can just like look at it and not be overwhelmed with data and see an interesting group.
We had a talk at QCon, I think London, a year or two ago, with like straggler reduction in data flow. That was pretty awesome. I think it was data flow, right? Yeah, it was. I think that was pushing the envelope. It basically said it can reduce your times by 25 to 50% by splitting your job on the fly without any prior history of the job. I think that was amazing.
So I'm going to ask a quick follow-on to something that you said a little bit earlier about, slightly flippantly, I think, about hiring more managers. So given how many data scientists have PhDs, do their managers have PhDs? Do you need specific skills to manage a team of data scientists?
I think you have to be able to deal with a lot of prima donnas. And I don't think you need a PhD to be able to do that. But that's just my take on it.
From what I found, it's very important to have the right culture for the team. So basically try to establish a culture and find people that are most excited about actually solving the business problems and making the companies successful, and having that in there, and having people be rewarded for that and so on. So if you do that, it depends what you want the manager to do. If they're kind of a tech lead too, they should understand what's happening, but you could also have someone who's a great manager who understands the business and who understands how to help people in their careers, but isn't a PhD.
The specific question, I think, was, do you have to have, or does being a PhD make you less of a manager, or do you have to have a PhD in order to be a manager?
Do you have to have a PhD to manage a data science team?
Yeah, so I don't think you necessarily have to have a PhD. I think some deeper expertise or like exposure to at least the tools in the tool shed is kind of useful. So this is like I have a master's degree, I don't have a PhD, but a lot of my team does.
I don't think you have to have a PhD, but you can, of course, as Stephanie said, you can substitute for it by having a deep expertise, which in a lot of ways in this industry is really just applied, experience, right? One thing though I would like to say is that after a PhD, you realize that you don't know anything.
Very nice.
So, that is actually, pretty refreshing.
So much time learning that.
Yeah, exactly. So in that respect, then you need a strong manager who understands, that aspect of somebody who has really attained knowledge, really knows that I really don't know anything. And therefore that manager would then be able to, really distinguish between the prima donnas, as you said, and the ones who are humble. And then, of course, you'll always have, you have to have some deep conversations, and, you have to actually have rebuttals, but I strongly believe in then having a manager who is very skilled at conflict resolutions and making sure that everyone can, let's say, disagree but still commit, which is what Jeff Bezos says at Amazon. So I think those attributes are more core than having a PhD in order to be a good manager.
Are there different skill sets that you look for a manager for a data science team? Are they the same that you would for a front-end JavaScript team?
No, front-end manager may not translate directly into any data manager type role. So there has to be some domain expertise, right, for sure. And that is, in a sense, in order to, let's say, just understand at a very high level and what the team is working on and be able to have a vision and articulate it such that the team actually buys into it. So that's where the skills have to actually still be domain specific.
So you have to have some credibility in the domain.
Yeah.
Okay, I think we have another question over here. Roland?
Yes, thank you. Now the world of AI is going super fast. Data science is just, there's so many knowledge coming in. How do you make sure that your team keeps up to date with all the new knowledge that's being published lately?
How do you keep up to date with all the stuff that's happening? Yeah, by coming to events like this, right? Yeah, I learned quite a ton. Yeah, I usually, when I go to conferences, I'm usually hanging out in the hallways, but I have attended all the talks. And not that, because I'm the track host, but still, I found all the talks that I attended in my track really useful. So yeah.
Yeah, I mean, I think building time for it in the day is also pretty important. So like we have like quant hour research meetings. We'll send around papers. Like I think a lot of it is just encouraging people to do that. One other thing that is convenient is if you hire people who are going to do it anyway, then they'll like do it on their own time as well.
The one thing I'll add to this that I've seen is having a way to quickly test out some new idea and see whether it would actually help in your case, which is good practice anyway for most of the things you do in data science. But if it's very easy for someone to like try a new model and compare it with your existing one or something, then you're more likely to benefit from them. If that is a huge process of like even discovering how to bring together all the right inputs, people are just not going to do it.
So I want to go back for a second. Sid, earlier you mentioned Conway's Law. So I want to ask a question about engineering teams and data science groups. Should they be separate teams? Should they be grouped together as cross-functional teams? Does it depend on the domain? How do you structure your teams?
I think what Matei said earlier made total sense to me, which was that you have the two models. One model is you have vertical teams. They're vertical by domain. And so they're working in some domain. And in that domain, they work with the like biz dev or the product manager, and that's telling them what the business needs to do. And then together, the team kind of organizes as a scrum, and you have the data scientist generating the models or testing the models or validating the things, and then you've got the sort of the data engineers helping out where they can. The negative of that is it's like the Wild West. Everyone's using your HDFS as their like Scratch. And there's no organization, and so it's very hard for one team to share the data that another team can use. So then what happens is they say that, this doesn't work anymore. We need a central team. And that central team will organize how the lineage of that data, right? The governance, the provenance of this data. But then that team becomes a bottleneck, right? And so I very much saw this at LinkedIn when I was there. I think I came at an interesting point where they said, okay, so we had this, on HDFS, we had this thing called data/data. Okay, that was like where you put data. Okay, then there was another thing called /data derived. That's where you put derived data. Okay, so there was only basically two states. It either came, and there was like /data databases. Like it came from a database, right? Now the problem is with derived is someone took something from a database and enriched it with derived and then put it back in derived. And then someone took that derived and put it back in derived, and then nobody knows who owns the original thing that they had. The lineage becomes a huge mess. So you need this policing force at some point to handle this. Otherwise, it goes nuts. But yeah, you end up getting a bottleneck.
Yeah, just to tee off of what Sid said, I think, the best functioning model that I've seen are ones where, they're all aligned across a functional unit. Like search engine companies like Yelp, where I used to work before, they've done a pretty good job. Like they have data mining teams, which has machine learning engineers, backend engineers, and data engineers all just working together, solving for either search or ads or spam. And we've tried to do the same thing at Coinbase as well. Everyone who's working on the risk side of the org, they're just working together, risk engineers, risk analysts, data engineers, and machine learning engineers. So I feel like that is the best way to keep the whole machine moving smoothly. Anything to add?
I will add this one thing from Conway's Law. I can't list exactly which company it is, but a company I've been affiliated with, or maybe currently affiliated with, goes through reorgs. And because the org boundaries keep changing, there's a lot of jobs that are running that have no owners. Like tens of thousands of jobs that are running that nobody owns anymore because I don't think this is a solved problem. I'm curious what other people think or have seen.
Yeah, I don't have a comment on this specific problem, but definitely, I mean, it is very important to document like all the steps involved in producing a specific data set, and if others are going to build on it, you need a plan for how you're going to keep producing that. All these data sets are live, basically. They'll keep being updated. Something will fail in the future. Someone will need to go back and understand what's in there.
So somewhat related to Wes's question, what do you think data scientists could learn from software engineers? I know from experience, for example, that mathematicians write horrible, horrible code.
Yeah, I think, so I'll just talk a bit about this. I think in general, there's no established software engineering process around data science, and even in some ways around just data analytics in general, certainly not around machine learning. So I think there'll be a lot of stuff, and people are coming up. For example, we had this question about whether there's a way of packaging models and shipping them. People are coming up with solutions to specific areas here, and there are just some basic things that we do in software engineering, like using version control or being able to hold back code, but also things that are specific to data science. For example, how do you monitor a machine learning based system? It's not just like, is the server up or down? It's actually a pretty complicated problem to figure out how it's doing. So I think this is an exciting area where people will discover things. And one analogy I have is it's kind of like the early days of the web. It used to be very difficult to build a web application, required lots of arcane knowledge across many different things. And today people figured out ways to package them and frameworks that make it possible to build them. And as a result, it's maybe 10 or 100 times easier, and companies build 10 to 100 times more web applications. So I think we can get to that stage if we define sort of the right processes.
So in today's conference, we have many sessions that went through some of the good practices and tech stack that show us how to productionalize, machine learning and models and whatnot. For companies that more doing traditional development right now want to tap into the benefit of ML, what are the top 3, let's say, tech stack or patterns that you would recommend these companies to invest in and get good at?
Yeah, I think Apache Spark might be. I heard it can do data stuff and machine learning, so that's one thing. I don't know. Yeah.
I think the cloud-based, the public cloud ones now are just amazing. So both Google and I think Azure also has Azure ML, but I've never had experience with it. But I think the things that are available in the cloud today that's great if you can use it.
Yeah, and Amazon has SageMaker as well that we've been playing with. But if you wanted to have a tech stack, which is in-house, then if you want to have ability to actually productionize code faster, etc., then Python or Scala or any Java-based language. I have found it difficult to productionize anything with R. It's quick to prototype, but hard to productionize. Although there are several companies which have successfully productionized with R too. But if you want to set yourself up for less pain in future, stick with Python or Scala.
I've been thinking about cognitive diversity a lot. That on a team you can have people with very different skills, and you want to let them all contribute in their own way, but still wind up with data products that they can all work with. So how do you balance the cognitive diversity of people versus commonality for a team?
So one idea is if you run in a Scrum team, at the end of the sprint, there's a demo. As long as you show the worth of both groups or all 3 groups, I think then you're going to send the message that all of those disciplines are important or equally important.
I'm here thinking about how I'd represent myself on an histogram. My question is, what mistake in building out data science capabilities, fresh, what mistakes do people make that you could help us avoid? And then also, as you get going and you think you've got it down, what are the traps people fall into that you should try to avoid?
Yeah, if you are really starting a data team from scratch, then I don't think your first hire should be, what in the Valley people call data scientists, right? Or in my histogram, that's a quant. The reason for that being that that quant would then need support in order to actually productionize whatever model or algorithm they came up with, right? So unless you have a colleague on the other side, who's going to help the quant actually productionize it, then don't hire your quant as the first data hire. I would almost say you should be hiring either a data analyst as the first hire if you just want to derive insights first, or you should be hiring a data engineer if you don't even have a data warehouse, right? So those would be my first hires. And then If you're really just starting, then you probably don't even need machine learning just yet. You probably just need a data analyst to give you insights to the data, and even probably can get away with a rules-based system. And then eventually you hire a machine learning engineer, right? Yeah. Anything to add?
Yeah, I think in terms of pitfalls, one of the main ones I've seen is if you don't have a metric of success that you've thought about very clearly and that you can keep monitoring. And then the second one I've seen is you collect some initial set of data, you do something with it, you got a result, but then you can't reproduce that later or change it as new data arrives. So you really need to think about that, both like how are you going to run this again, and also how are you going to measure that same metric. And I've seen a lot of the people that I work with who have lots of data science experience, they begin by defining those metrics. That's like the first thing they work with any project, is how do we define that?
So yeah, it's definitely, I think, related to the metrics is like, once again, what is the problem that you're trying to solve? Like if you're starting out and you're trying to convince your colleagues that investing in data science is a good idea, a lot of times you want to sort of find that really nice problem that it will just very, very cleanly solve, right? So if you're in operations, it's like, okay, let's figure out how to optimize different components of that. I think that there are some more hairy problems that don't need to be in production. So this is a little bit different than I would say a quantitative analyst, but people who are trying to help people make deeper decisions. So it's sitting there and really pulling out the confounding variables. But then once again, like that position is not going to be as high, as clearly high ROI.
Okay, I think we have time for one more question.
Data science is such a perhaps intrinsically sophisticated discipline that it's difficult to intuit your way through such a complex solution sometimes. So as an executive building out a data science competency, how do I protect the org from human error?
How do you protect the org from human error?
Yeah, what controls can I put in place that can protect us from human error out of a data science team? Because people make mistakes, but with such a complex solution coming out of it, there's no way for me to know if there's a mistake being made.
I see. Yeah, no, I think that that's fair. I think that there's sort of things that you can put in place. Like if there's certain problems that you're trying to solve that are important enough to understand, then you can just put that as a constraint on the data science team. You can say, hey, guys, like we need to use a really interpretable model right now because we actually need to be able to peel it apart and understand what's going on. Yeah, so I'd actually just say put it as a constraint for people to work under, because like there's some things where it's like, you know what, using deep nets is not going to get you what you want. It might be a little bit too complex and you have no idea what's going on.
What I found is like you often need to try the simple thing as well and compare with it. And also the metric you're measuring needs to be very well defined. So that's the thing that an executive should understand. If they don't understand that, then of course they won't be able to make a decision. And then, compare it with like a linear model, compare it with some very simple thing. Often that will give you a baseline that's pretty interesting to see.
I think one thing to add to that, Rachel's keynote tomorrow evening will cover quite a lot of the same ground. So make sure you come along to that one as well.
All right, so what do you think of our first ever live recording of the InfoQ podcast? All right, so we should do it again. All right, keep it going. Thank you to our panelists. Thank you so much for joining us. And once again, thank you for joining us on the InfoQ podcast.